Hi students, in this class we shall be discussing partition values or fractiles. We have discussed what is arithmetic mean, what is median in the previous classes. If you have not seen those videos, you can check the I button where you will find the links for those videos. So then in this class we shall be discussing partition values or fractiles. So what are partition values? What do we mean by partition values? This will be the question of today's class. So suppose if we have a set of data and we need to partition the whole data into many parts. So we shall consider certain measures which partition the data into many parts. Certain observations will divide the whole set of data into many parts. So they are median, quartiles, deciles and percentiles. Okay, they are median, quartiles, deciles and percentiles. Median is used, suppose if we want to partition the whole data into two equal parts. So this will be the median. So half of the observations will be less than the median, half of the observations will be greater than median. Same way, quartiles. What are quartiles? For quartiles, what we do is, suppose if we have a set of data, this is the range of data. So if you want to divide it into four equal parts, so first in the middle, okay, and then what we have, we make two more cuts here. So this is the first quartile, this is the median actually, which becomes the second quartile, and this becomes the third quartile. Okay, this is your observation, the leftmost observation and the rightmost observation. And same way, deciles are used to partition the whole data into 10 equal parts by 9 points. Same way, percentiles are used for distributing the whole data into 100 pieces, okay, by using 99 percentiles. Okay, so that is it. We shall discuss each one of them in detail. First, we will start with the median, okay, as a partition value. Okay, so when we want to divide the whole set of observations into two equal parts, then we consider the median. Okay, that is, as we have shown in using the line, that if you want to divide the whole set into two equal parts, we use the median or the central value to divide it into two pieces. Okay, we can observe that half of the observation are less than the median and half of the observation are more than the median. Okay, so how to find these? Okay, for unclassified data, we have already studied that median is the n plus 1 by 2th value. Okay, it is n plus 1 by 2th value. So if there are 5 observations, so 5 plus 1 is 6, 6 by 2 will be 6 by 2th value. Okay, that is for unclassified data. Now, the partition value for continuous data. For continuous data, median value is given as L1 plus n by 2 minus nl by nu minus nl into c. We have discussed these points in detail in our previous video. You can check the video for the topic in detail. Okay, so we shall now move on to what are quartiles. Okay, what are quartiles? Quartiles are used when we want to divide the whole set of data into 4 equal parts. Okay, quartiles divide the whole set of data into 4 equal parts. So they are 3 quartiles. There are 3 quartiles. The first quartile, it is denoted, or the lower quartile. First quartile or the lower quartile, it is denoted by Q1. Okay, it is denoted by Q1. So we have Q1. Okay, so the second quartile, or it is also the median, which is denoted by Q2 or ME. Okay, when we refer it as a quartile, we use Q2, otherwise it is the median. Okay, this is the second quartile. And the third quartile or the upper quartile, okay, third quartile or the upper quartile, highest quartile, it is denoted by Q3. Okay, it comes here. Okay, so we can observe that 25% of the observations are less than the first quartile. See, 25% are less than the first quartile and 75% of the observations are greater than the first quartile. Same way, when we discuss about the second quartile, 50% are less than the second quartile and 50% are more than the second quartile. Same way, for the third quartile, 75% is less than the third quartile and 25% is more than the third quartile. Okay, so that is what we have in the quartile section. Let us see how to find out the quartiles in case of unclassified data. In case of unclassified data, we have, see, this is first quartile, this is second quartile, and this is the third quartile. We use the quartiles to divide it into 4 equal parts. Okay, that is what we discussed just now. Now, for the first quartile, to find the first quartile for unclassified data, the formula given is n plus 1 by 4th value. First quartile is n plus 1 by 4th value. Okay. Now, the second quartile is given by 2 into, see, here we multiply the quartile number with n plus 1 by 4. Okay, that's it. So, this is second quartile will be given by n plus 1 by 4th value. Third quartile will be given by 3 into n plus 1 by 4th value. Okay, so that is if you want to find out the pth quartile, then we use, see, we have n plus 1 by 4 already. Okay, we multiply that with the value p. If you want the first quartile, we use 1 here. If you want the second quartile, we use 2 here. If you want the third quartile, we have to use the value 3 instead of p. Okay, that is value. Okay, so that is the pth quartile. We can find out the value of the pth quartile. Okay, so in case of the continuous data, we shall be using the formula similar to that of median, but instead of our n by 2, we have p into n by 4th. Okay, the process is the same. We prepare the table also in the same way, prepare the less than type cumulative frequency distribution, and then what we do is we will find out n by 4 first of all, p into n by 4. Okay, p into n by 4. If you want to find out the first quartile, we use n by 4. If you want to use the second quartile, we use 2 into n by 4. If you want to use the third quartile, we will be using 3 into n by 4. Okay, find those values and observe, check where it lies in the cumulative frequency distribution. Okay, in the cumulative frequency column, and the corresponding class will be called the quartile class. Okay, and then everything else will be related to that quartile class, like the L1 will be the lower boundary point of the quartile class, NL and NU and NL are all defined in the same way as that of median for that particular class. Okay, we shall see this in detail when we solve the examples. Okay, so let us move on to deciles. What are deciles? So deciles are those values which divide the whole set of observations into 10 equal parts. The same way, median divides it into 2 equal parts, quartiles divided into 4 equal parts, deciles are used to divide the whole data into 10 equal parts. So we have 9 deciles. 9 points can divide the whole thing into 10 equal parts. So we have, this is D1, this is D2, this is D3, this is D4, D5, this is D6, this is D7, this is D8, this is D9. So there are 9 deciles and 9 points can divide the whole set into 10 equal parts. So same way, if you take any particular decile, okay, so it is like that. So these many number of observations, say for example 20% of the observations are less than that of the second decile, and the remaining, that is 80%, are above that of the second decile. To find the value for unclassified data, we use the denominator 10 here. Okay, instead of 4 for quartile, we will be using 10 for decile because it is dividing it into 10 parts. In median, we used it 2. We used to divide by 2. In quartiles, we used to divide it by 4. In deciles, we will be dividing it by 10. Okay, so n plus 1 by 10th value. Same way for the second decile, we multiply 2 to it. For the third, we multiply 3 to it. And for the 9th decile, in the same way, we use 9 into n plus 1 divided by 10. Okay, now we shall move on to percentiles. It is similar, everything is similar except that it divides into 100 parts. Partition value percentiles. Okay, so what are percentiles? Percentiles are those values or those set of observations which divide the observations, given set of observations, into 100 equal parts, So they are named as P1, P2, P3 up to P99. Okay, so Everything is defined in the same way except that the denominator is 100 here for the formula, and it is denoted by P1, P2, P3, P4 up to P9. Okay, the 99 points divide the whole set of data into 100 parts. So I cannot show them here. Say for example, up to here, this is A, this is B. Okay, we have say P1 here, P2 here, and it will go like this, and we have P99 here. Here P50 will be the median. Okay, 50th observation, 50th percentile will be the median. Actually, it lies in the center. We need to observe that it is 100. We divide by 100 here. Okay, for percentiles. Now, how to find the percentiles or fractiles? Let us understand this. So this is a summary of what we discussed right now. For quartiles, the data is divided into 4 parts with 3 quartiles. For deciles, the data is divided into 10 parts with 9 deciles. And for percentiles, the data is divided into 100 parts with 99 percentiles. Okay. So, the formula to find out individual data will be, the formula to find out the quartile for individual data will be k into n plus 1, p or k. Okay, pth quartile or kth quartile will be k into n plus 1 by 4. In this case, it is 10 here in the denominator for the kth decile, where k can be 1, 2, 3, 4, 5, 6, 7, 8 or 9. Same way for pk, where 1 to 99 values can be taken for k and divided by 100, k into n plus 1 by 100. Okay. Now for continuous data. For continuous data, what is the formula? Formula we have is this one. It is a pth partition value. It is the pth partition value where L1 plus, it is given by L1 plus NP minus NL into NP minus NL into NU minus NL, where this NP is defined as P into N by 4 for the quartiles, where P is 1, 2, 3 for the first, second and third quartile respectively, and NP will be taken as P into N divided by 10 for the deciles, where P can be taken as 1, 2, 3 up to 9. Same way, NP for the percentiles will be P into N divided by 100, where P can have the values 1 to 99. C is the class length of the partition class, whichever it is. But okay, if it is the second percentile, we say about that it is about the second percentile class containing the second percentile. Okay. We can also find partition values for a grouped frequency distribution by drawing ogives, that is less than type frequency. The corresponding value, this particular value of NP will be taken on the y-axis, and we draw a horizontal line. Wherever it intersects the ogive, we draw a perpendicular to the x-axis. Wherever the point meets, wherever the line meets, that is the foot of perpendicular of that line will be called the partition value. Okay. That's it. Now we shall move on to the concept practice problems, where we shall discuss all these questions or all these formulas. Okay. So question number 3. Concept practice problem number 3. Okay. First two were that of median, which we already know. Now we try to find out the first quartile, deciles and percentiles. Median is what we discussed in the previous class. Okay. So following are the wages. Okay. We have the wages of the laborers. So this is 82, 56, 90, 50, 120, 75, 75, 80, 130 and 65. Okay. So how to find the first quartile or the decile or the percentile? To find partition values, the first step is to arrange the data. Let us arrange the data in an ascending order. Okay. So the values are 50, then we have 56, then we have 65, then we have 75, then again a 75, then we have 80, and then we have 82, then we have 90, and then we have 120, then 130. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now to find the first quartile, this is ungrouped data, right? Ungrouped data, we find the first quartile, Q1. Q1 will be given by n plus 1 divided by fourth value. Okay, n plus 1 by fourth value. So what is that? N is equal to 10. N is equal to 10 here. Okay, we have n equal to 10. So n plus 1 by fourth value, 10 plus 1 is 11, 11 by 4. Okay, we have 10 plus 1 divided by 4, the value. Okay, so 10 by 4 is nothing else but 11 by 4. And what is 11 by 4? 11 by 4 will be 2.75. Okay, that will be equal to 2.75. So it lies between the second and the third observations. So what we need to understand here is, say for example, this is the data distribution, and this is the second observation, and here we have the third observation. The lies between the second and the third observation. Lies between the second and the third observations. We have the second observation here and the third observation here. And where does this first quartile lie? The first quartile lies somewhere here. Okay, 2.75 comes somewhere here. Okay, this point. That point is the first quartile. Okay, how to find here? Up to here, this value will be the first quartile. How to find this? Let us try to understand this concept. So to do that, let us move further. So first of all, we will take, this will be equal to the second value. Okay, second value plus 75% or 0.75 into 0.75 into, let me write 0 here, 0.75 into the distance between 2 and 3. Okay, the distance between the second observation and the third observation, difference between the third observation and the second observation. Third observation minus third value minus second value. Okay, so that is, which is the second value? Second value is 56, and then the third value is 65. Okay, second value is 56 plus 0.75 into, what is the third value? Third value is 65 minus the second value again, that is 56. Okay, so this becomes 56 plus 75% of, that is 0.75 into 65 minus 56. What is 65 minus 56 into 0.75? What is 65 minus 56? We shall write it here. This is 65 minus 56 will be equal to 9. Okay, so we shall put 9 here. So the final value when we calculate 56 plus 0.75 into 9 will give you 62.75, will give you 62.75 rupees. Okay, so this is how we find the first quartile. In case if we are asked to find the second quartile, we will be taking 2 into n plus 1 by fourth value, that is multiply this by 2. Okay, and then we take the corresponding values. Let us understand that using the D6. For D6, what happens? Okay, now let us find the sixth decile. To find D6, what can we do to find D6? To find D6. To find D6. What is the formula? Sixth decile, okay, D6 will be equal to, see, it is n plus 1 by 10 decile, okay, into 6, sixth decile, okay, that much Okay, so let us find that. What is n plus 1 by 10? N plus 1, what is n? N is 10. 10 plus 1 is 11. 11 by 10. 11 by 10 is, so this is 6 into 11 by 10. The value. Okay, so that becomes equal to 11 by 10 into 6. 66 divided by 10. This is 66 divided by 10th value, that is 6.6th value. 6.6th value. How to find the 6.6th value? It is, see, we know that if it lies between the 6th and the 7th observation. Okay, 6.6, 6.5 will be somewhere here. So 6.6 will be somewhere here. This is our decile, 6th decile. Okay, it lies between the 6th and the 7th observation. 6.6 lies between the 6th and the 7th observation, not the 6th observation, not the 7th observations, but little more than half the distance. That is what we need to understand. Okay, so that is, we divide it into two pieces, the integer part and the fractional part. So that is 6th value plus, what is the fractional part? It is 0.6 into the difference between the 7th and the 6th observation. Okay, so that is 7th observation or 7th value minus 6th value. Okay, so that will be equal to, what is the 6th observation? This is the first one, second one, third one, fourth one, fifth one and sixth one. So this is the region which we need to, this is the 5th observation and this is the, sorry, let me check this out, 1, 2, 3, 4, 5, 6 and 7. This is the data, this is the 6th observation and this is the 7th observation. Okay, so 6th value is 80 plus 0.6 into 7th value. 7th value is 82 minus 6th value is 80. Okay, 82 minus 80 is 2 into, this is 0.6 plus 80, which will give you, this is 0.62, so 12, 1.2. Okay, this is 80 plus 1.2, which will be equal to 81.2, 81.20. Okay, that is the 6th decile. So 6th decile will be rupees 81.20. This is the 6th decile. Okay, same way we can go for the percentile. For percentile, what we have the same value here. Let us paste the data here and we need to find out the 82th percentile, 82nd percentile. Okay, 82nd percentile. How can we find the 82nd percentile? How can we find the 82nd percentile? Okay, so to find P82. Okay, so we need to find out the 82nd percentile. Formula will be the same. 82, P82 will be equal to 82 into n plus 1 divided by 100 here in this case. Okay, 82 into n plus 1 by 100th value. Okay, so that is 82 into, what is n plus 1? N plus 1 is 10 plus 1 is 11. 11 by 100 into 11 by 100. When you multiply this, what you get here, the value. What you get here is 9.02, 9.02th value. Okay, we know that 9.02 lies between the 9th and the 10th observation. It lies between the 9th and the 10th observation. Somewhere here. Okay, this is 9.02. 9.02, somewhere between this. Okay, so that is P82 will be equal to 9th observation or 9th value plus 0.02 into the 10th observation minus the 9th observation. 10th value minus 9th value. Okay, so that will be the 9th value is 120 plus 0.02 into what is 10th value, 130 minus 9th value is 120. Okay, we can see here. Okay, so finally this is 120 plus 0.02 into 10. Okay, 130 minus 120. So this is 120 plus 0.2, that is 120.20. 120.20. Hope you have understood how to find out the deciles, percentiles and quartiles using simple data, that is ungrouped data. Now we shall try to understand how to find out the deciles, percentiles or quartiles using continuous data. Okay, let us consider the following question for continuous frequency distribution. Okay, so here we have the following distribution. We need to create to find the partition values Q3, Q7 and P23. We need to find out we need to convert this thing into less than type cumulative frequency distribution. So let us create the less than type cumulative frequency distribution. We have the class here or wages. Okay, class, and the classes will be distributed, or the lower boundary point of each class shall be taken. Class boundary points. Class boundaries. First we have an extra class at the top, that is, say, let me take it as a lower boundary point because here it is an unbounded part, so less than something, and then this is not exclusive. We need to convert them into exclusive. So therefore, see, we can see here that it is not, this is 899, this is 900. So in between it is not connected. So we need to make them exclusive class intervals. So that is 499 will be the boundary point of this class. So that is 499.50. Then we have 699.50 for this. Then we have 899.50. Then we have 1099.50. Then we have 1499.50. And then after 149.50, there are some more items, so that it will be, the upper boundary point is not known to us. Let it be U. Okay. Now the corresponding cumulative frequency, that is less than type cumulative frequency, less than type CF. Okay, less than type CF. So what are the less than, means how to find the less than type CF? We need to keep adding these values. So first one, less than the lower boundary point is 0. Okay, now less than 500, that is 499.5. Less than 499.5, it is 5. Less than 699.5 is 23 plus 5, which is equal to 28. Okay, we have 28 here. Same way, less than 899.5 will be 29 plus 23 plus 5. Okay, which is equal to 57. So we have 57, and we can move further like this. We have 84 here. Then we have 94 here. Okay, and for the highest upper boundary point, what we have is 100. Okay, all the observations, there are 100 workers. Okay, so the whole classification is done. Now let us find out the third quartile. Okay, so we know what is the pth quartile. Pth quartile will be equal to L1 plus NP minus NL by NU minus NL into C. Okay, where NP will be given as the NP has a different formula, where NP is equal to, in this case we need to find the third quartile. So therefore we will be taking 3 into n by 4. Okay, which is equal to what is the total number of observations? It is 100. So it is 300 divided by 4. So 300 divided by 4 will be equal to 75. 300 divided by 4 is equal to 75. So let us observe that where does this NP lie in the cumulative frequency curve? 75 lies somewhere here, somewhere here. So in this case, we shall focus on this region, We shall focus on this region. Okay. So as we did in median, this is the median class, the quartile class, third quartile class, or the class containing the third quartile. So here this is L1. Let me take a different color. So this is our L1, this is your L2, this is your NL, this is your NU. We have our NP here. Okay, the difference between, or the class length C can be taken as 1099.50 minus 899.50, which will be equal to, say, 200. 200 is the class length. Okay, so therefore Q3 will be equal to, what is L1? 899.50 L1, okay, plus NP in this case was 75, okay, 75 minus, what is NL? NL is 57 divided by, see, minus 57, this is as it is. Now we need to find NU. NU is 84. What is C? C is 1099, L2 minus L1, right? 1099.50 minus 899. So that is equal to 200. So you can calculate this thing. When we calculate, what we get, the Q3 as, Q3 will be 1032.83. It will be equal to 1032.83. Okay. So this is the third quartile. This is the third quartile. Same way we can go for the deciles. Just the small difference for a decile is that in that case we will take, for the seventh decile we will have 7 into n by 10. Okay, let us see that also. Okay, so let us consider for the seventh decile. For the seventh decile, let me bring the data here. This is our table, and to find D7, right? D7. What we do? We first find what is the formula? Formula is the same. Okay, pth decile dp. Okay, dp will be equal to, what is the formula here? The formula is L1 plus NP minus NL divided by NU minus NL into C, where NP, here NP will be equal to, what is the P? P in this case is the seventh decile, right? So N7, this is N7 will be 7 into N, that is 100 divided by this is decile. So we have 10. Okay, so that is equal to 70. Now let us observe, where does 70 lie? 70 lies here itself. 70 lies here in the cumulative frequency section between 57 and 84. So we again focus on this region. Okay. So in the same way as the median class, we find the seventh decile class as 899.50 to 1099.50. It is a coincidence that we got the same class. So this is our L1, this is our L2, this is our NL, and this is your NU. Okay, here we have our 7 into N divided by 10. So let us put everything else in the class. The same class length will be 200. Okay, what is L1? L1 is 899.50 plus, what is NP? NP is 70 minus NL is equal to 57 divided by NU. What is NU? NU is 84 minus 57. Okay, so into C. C is 200. Okay, we have the class length C as 200. So when you calculate this thing, what we get is D7 will be equal to 995.80. So D7 is equal to 995.80 rupees. Okay, so same way we can go for the percentile, which how much percentile? 23rd percentile. We need to find the P23. Okay, we first of all find N23. That will be equal to 23 into N. 23N divided by 100 in this case, because we are dealing with the percentiles. So that will be equal to 23 into N was 100 divided by 100, and that is equal to 23. Now we need to observe, where does this N23 lie in this? So it lies somewhere here. It lies somewhere here in the cumulative frequency table between 5 and 28. So in this case, we are focusing on these two regions. Okay. So this is our L1, this is our L2, this is your NL, and this is your NU. Correct? Now let us use the formula. What is the formula? Formula is P23, or the quartile, not the quartile, the percentile will be equal to L1 plus NP minus NL divided by NU minus NL into C. Okay. So that will be equal to, what is L1 in this case? It is 499.50 plus NP. What is NP? NP was, that is N23, that is 23 itself. So it is 23. What is NL? NL is 5 divided by NU minus NL, that is 28 minus 5 into C. What is C? C is 200. So which, when calculated, will give you 656.02. 656.02. It's this much rupees. So we know how to find out the percentiles, deciles, and the median. Okay, we know how to find out the median, we know how to find out the quartiles, we know how to find out the percentiles. So that is, all these are called fractiles. Okay, they divide the whole data into different fractions, partitions or partition. So therefore, this was the topic for today, and I hope you practice more problems, and we shall be discussing more problems in the coming classes. So goodbye for today.